Hello, I'm standing here with Johannes Laur. First of all, can you give us a quick introduction of yourself and maybe what's your part in the project?
Hi, my name is Johannes. I'm a Ph.D. student at the University of Luxembourg. My research is part of the MEESST consortium here. I am analyzing the radio communication blackout part of the project, which means I am trying to design a numerical tool, so a software, which can give an estimation of the signal propagation through a plasma cloud, which we then also want to change and to improve the signal quality and the signal path, applying a magnetic field, a strong magnetic field, to then reduce the signal degradation we have during the blackout, during the atmospheric entry.
That sounds interesting. And over the past 3 years that you've worked on the project, what would you say was the biggest challenge to overcome condition-wise?
So in the last 3 years we had a few challenges, I would say. First of all, the COVID, then we also had the war in Ukraine. COVID had the influence on our work that we were not able to meet actually in person together, which complicated a few things, for example getting together to the common goal. Also the motivation wise is a little bit more tricky because you don't see your the people you work with from the whole consortium, and also the war in Ukraine increased prices a lot, so the inflation goes up, which brought some budgeting problems at some points. I think that's it.
Okay, and technological-wise, what was there the hardest challenge you guys had to overcome?
So technological-wise, first of all, the experimental setup. Applying a superconductive magnet, so a magnet without any resistance. Developing the whole experimental setup with the cryocooling system to keep the temperature of the superconductive magnet in the superconductive area, which is around minus 270 degrees Celsius. And then also from my personal side of my research is interdisciplinary, so I'm working on one side on the plasma physics, on the other side on the communication aspect. I'm quite new to the communication part of my project, which means I had to get into this topic from scratch, which was also challenging, but I think we're doing a good job right now.
And as a last question, what would you say was the greatest achievement up to this point from your part of the project?
From my part, I would say two things. First of all, we had shown from experiments that were done several years ago with small magnetic field strength that we can already alter or change the magnetic field, the signal propagation path, so how the signal is moving through the plasma cloud, even with small magnetic field strength. And I artificially increased the magnetic field strength in my simulations, and this showed that there is a huge potential applying a magnetic field to overcome the cutoff of communication during atmospheric entries, which is also an agreement with literature. And the second achievement is from my side that I finally developed a code in which I can calculate the energies along the signal propagation path, and do then the validation, so the comparison between the experimental results and my numerical tool, to be sure that my numerical code or the software is working properly.
That sounds very interesting. Thank you for your time and thank you for the interview.
Thank you too.